So let us start this session. So in our previous session, we have started with FSM design, and we have seen what do you mean by sequence detectors and what do you mean by overlapping sequence detection and non-overlapping sequence detection. And we have seen one example for Mealy FSM. We have drawn one state diagram for Mealy FSM. Okay. So let us continue the same problem. We will try to draw the Moore FSM for the sequence 101. Okay, we will try to draw the Moore FSM for the sequence 101 and it is non-overlapping. Let me write down here. So let us try to draw the sequence state diagram for the sequence 101 Moore FSM and it is overlapping. We need to design a Moore FSM overlapping sequence detection. Okay. Now, how to design this? Let us try to understand. Uh, we are going to consider the non-overlapping. First, let us consider the non-overlapping. Then we will go to the overlapping. Okay. And I want to draw the Moore FSM. Okay. So the same circuit I am going to consider. This is my circuit where I am going to have a clock signal, a reset signal, and an input signal which is a serial input. This is a serial input and I'm going to get my output. Whenever the sequence has been detected, I'm going to get my output is equal to 1. Okay, whenever my sequence has been detected, I'm going to get my output is equal to 1, else my output will be equal to 0. So if I apply my reset signal, I'm going to a state which is known as idle state, you can say, okay, where your output is equal to 0. So in the case of your idle state, no sequence has been detected. In the case of idle state, no sequence detected. This is the state. Now, if I apply 0, so in the case of ideal state, I have two options. One is either 0 or either 1. If I apply 0, I am going to stay in the same state. I am going to stay in the ideal state itself. Okay. But if I apply 1, I am going to a state which is known as S1 state where my output is still equal to 0. Where my output is still equal to 0. Where S1 state is a state where one bit has been detected. One bit matching state. One bit is matching. S1 is a state where only one bit is matching. Now, if I am in S1 state and if I got one more one, I'm going to stay in the same state because only one bit is matching. Okay, and I'm drawing Moore FSM. No, I'm not drawing Mealy FSM. I'm drawing Moore FSM. Okay. Now, in if I am in S1 state and if I got 0, then how many bits are matching? Then 2 bits will be matching. If I got one more 0, then 2 bits are matching. Okay. So S2 is a state where 2 bits are matching. Where 2 bits are matching. So S2 is a state where 2 bits are matching. So I'm going to a state which is known as S2, where your output is still equal to 0. Okay. Now, if you are in S2 state and if you again have two options, either one is 0 or 1. Okay. Now, if you are in S2 state and if you get 0, what should be your next state? Can anyone tell me? If you are in S2 state and if your input is equal to 0, what is your next state? If you are in S2 state and if your input is equal to 0, what is your next state? Can anyone tell me? Any guess? Okay. So if you are in S2 state and you have already you got 1 0, okay, and if you get one more 0, then the sequence will 1 0 0 0. Yeah, which state you are going to go? If you are in S2 state and if you get 0, then which state you should go? What should be your next state? Is my question. So simply we will go to idle state if your input is equal to 0 because your sequence has not been formed. Okay. But if you get 1, you are going to S3 state by making your output to 1. If you get 1 when you are in S2 state, then your sequence has been detected and you are going to S3 state where you are making your output to 1. But in the case of Mealy FSM, if you carefully remember, if you are in S2 state and if you got 1, you are simply going to idle state. And if you got a 0 also, you are going to idle state. But in the case of Moore FSM, you are not going to go to idle state when your input is equal to 1. Why? Because your output is 0 in the case of idle state. You need to make your output to 1. That's why you are going to have one more state and you are going to make your output to 1. Okay. Now, if you are in S3 state, I will write down here S3 state, 3 bits are matching and here output is equal to 1 and here output is equal to 1. Now, if you are in S3 state, okay, and you have the sequence 1 0 1, If you are in S3 state and you have the sequence 101, and if you get one more 0, now which state should we go? We are in S3 state and we have got the sequence 101, okay, and if we have the input 0, then which state, what is our next state? Then we can see here, using this 0 we cannot form any sequence, okay, using this 0, 101 cannot be formed, okay. That's why what we are going to do, we are simply going to idle state, okay. And if we are in our S3 state and if our sequence we have the sequence 101, and if we get one more 1, using this 1 we can form 101, okay, and it is not overlapping also, okay. This sequence has been detected and we are starting from the fresh bit, okay. So if we get 1, then we will go to S1 state where at least one bit is matching, okay. So this is how we are going to design our Moore FSM for non-overlapping sequence. Is it clear? Anyone, any doubts or any queries here? Shall we move forward? Yes, I hope there is no doubt or any query in this particular things. Okay. Now, so let us try to understand Mealy overlapping sequence detection for 101 sequence detection. Okay, let us try to understand for the Mealy. Okay. Now, in the case of Mealy overlapping, we can overlap the sequence. Like, let's say, suppose if we have 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, like this. Okay. So, if we have a sequence like this particular sequence, then this has been detected, 101 has been detected, and we can also overlap with this previous sequence. Okay. And here our output will become 1. And here also our output is becoming 1. This is the case of our overlapping. This is case of our overlapping. But in the case of non-overlapping, what is happening in the case of non-overlapping? In the case of non-overlapping, if the sequence has been detected, then you cannot overlap with the previous detector sequence. You should start checking from here itself. Okay. This was in the case of non-overlapping. But in the case of overlapping, you can overlap with your previous sequence also. Okay. For this, we need to draw our Mealy Mealy FSM. Okay. Let us try to have that. So if I apply reset, then I will go to a state which is known as idle state, and I'm going to draw a Mealy FSM where your input is equal to 0, you are going to stay in the same state, and I need to detect 101. I need to detect 101. Now, if you have the input 1, then you are going to a state which is known as S1 state. Okay, and still your output is equal to 0. And your S1 state is a state where at least one bit has been detected, one bit matching state. And if you have 0, you are going to stay in the same state. Okay, and if you have one more 1, you are going to stay in the same state and your output is equal to 0. In the case of overlapping and in the case of non-overlapping, up to some extent the both FSMs will remain same. Okay, that I will show you. Okay, now if you have 0, then you are going to a state which is known as S2 state. Okay, and if you are in S1 state and if you have 1, you are going to stay in the same state. Okay, up to here, in the case of overlapping and in the case of non-overlapping, state diagrams will look same. Okay, now if we are in S2 state, S2 state is a state where two bits are matching. Okay, S2 state is a state where two bits are matching. Okay, now if we are in S2 state, we have the sequence 1 0. We have the sequence 1 0, and if we get one more 1, which state should we go? Can anyone tell me? I am talking about overlapping sequence. If I am in S2 state, I have already the sequence 1 0. Okay, and if I get one more 1, what should be my next state? In the case of non-overlapping, I was simply going to idle state. In the case of overlapping, what should I do? Can anyone tell me? What should be my next state if my input is equal to 1? Should I go to idle or should I go to S? Exactly. I should go to my S1 state. If my input is equal to 1, output is equal to 1. Okay. If you remember, when we were discussing about non-overlapping sequence detection, we were going to idle state because we don't want to consider the previous bit. Okay, so we don't want to consider the bit which is present in the previous pattern, but we are talking about overlapping sequence. We can overlap with the bit which is present in the previous sequence. Okay, so that's why I'm going to a state which is known as S1 state. I can reuse this. Okay, now if I am in my S2 state and if my input is equal to 0, if I am in S2 state and if my input is equal to 0, that is I have already 1 0, and if I get one more 0, then this sequence is no use. Okay, you cannot build 1 0 1 using this. Okay, that's why what you're going to do, you're going to idle state simply. If your input is equal to 0, output is equal to 0. Okay, let's say this case we have already discussed in our previous session also. Just again, let us see one more time. Let's say if your input is equal to 1, you are simply going to ideal state by making your output is equal to 1. Let's say, okay, let us try to see this. So what is that we are going to do? 0 0 1 0 1 0 1 0 0 0. We are talking about overlapping sequence detection. If the sequence has been detected, your output should become 1 here, and again you can consider the previous bit also in the previous sequence, and you can make this output to 1, and remaining all are zeros. Okay, this is the thing we are expecting in the case of overlapping. Okay, now let us see whether if we are going to ideal state, whether we are able to reach our requirement or not. Up to here we are in ideal state only, and here we are coming to S1 state, S2 state, and here what are we doing? If we get 1, we are going to ideal state, let's say, just suppose. Okay, and you're making your output to 1. Okay, yeah, this has been satisfied. Now again, if you get one more 0, you're going to S1 state. Okay, and you're going to S1 state and your output is equal to 0. And if you get one more 1, if you get one more 1, you're going to stay in the same state. You're going to stay in the same state. Okay, that is S1 state, and still your output is equal to 0. But what we need in the case of overlapping, your output should become 1. What is happening? Your output is still remaining to 0 only. Okay, that's why we are preferring to S1 state instead of ideal state, so that we can reuse that particular bit. Okay, that is the reason we are going to S1 state instead of ideal state. So this was a simple introduction of your basic sequences 101 with Mealy overlapping and Mealy non-overlapping, Moray non-overlapping also we have said. Okay. So let us see one more sequence which I've got, that is okay, non-overlapping double one double zero, double one double zero. Let us try to understand this, and let us assume that we are getting the sequence from the LSB. Okay, if you can also observe, you can also assume that you are getting the sequence from MSB, from which we will consider your wish, clock reset input, which is a serial input. Okay, so I'm assuming that LSB is applied first. Okay, okay, let's say MSB is applied first. Okay, from MSB the sequence has been given. Okay, that is first one is given, next one is given, next 0, next 0. Okay, then the sequence will be considered as detected, or else your sequence has not been detected. Okay, so that means if we get MSB 1, next followed by 1, next 0, next 0, then only your output will become 1, or else your output will become 0, or else your output will become 0. This is our requirement. Okay, now if we apply reset, then we are going to a state which is known as ideal state. So ideal state where your no bit is matching. Okay, no bit is matching. Now what is the first bit we need? We need 1. Okay, so we need 1. So if we get 1, your output is still equal to 0. You are going to a state which is known as S1 state. So S1 state is a state where at least one bit is matching. But if you are getting 0, you are going to stay in the same state. Your output is still equal to 0. Now if we get one more 1, then two bits are matching. If you get one more 1, your two bits are matching, you are going to a state which is known as S2 state. S2 state is a state where two bits are matching. Now, if you are in S1 state, if you are in S1 state, what you have the sequence? You have the sequence only 1. And if you get 0, then what do you think? What is the next state? If you are in S1 state, you have already the bit 1, and if you are getting input as 0, then what should be your next state? Same S1 or ideal? Can anyone tell me what is the required sequence we need? We need double one double zero, but what is the sequence we are getting? 1 0. So using 1 0, you cannot build 1 1 0 0. Okay, that's why what are we doing? We are simply going to ideal state because our sequence is not building. Ideal state. Okay, because our sequence is not building. Okay, your output is equal to 0 itself. Okay, now if we are in S2 state and if we get one more 1, okay, in our S2 state we already have two ones, and if we get one more 1, I can reuse this double one. I can reuse this double one. Okay, That's why I'm going to stay in the same state. That's why I'm going to stay in the same state. My output is still equal to 0. Okay. And if I am in S2 state, I have the sequence double one. And instead of 1, I am getting 0. Instead of 1, I am getting 0. Then how many bits are matching? 3 bits are matching. That's why I'm going to S3 state where 3 number of bits are matching. Okay. Where your 0 output is equal to 0 itself. Okay. So this is the sequence till now. Let me erase this. Okay, let me draw it here. Now, if I am in S3 state, if I am in S3 state and if I am having the sequence double one zero, okay, and if I get one more one instead of zero, I am getting one. Then is my sequence getting formed? Double one zero one. Is it matching with double one double zero? No, it is not matching. Okay, obviously it is not matching. So your output should be equal to zero itself. And what should be your next state is my question. Whether it is ideal state or whether it is S1 state or whether it is S2 state. Exactly. Why S1? Because you can reuse this single bit 1 for building this double one double zero. Okay. You can reuse this. Okay. That's why you are simply going to S1 state. And your output is equal to 0 itself. And if you are in S3 state, you have the sequence 110, and if you are getting one more 0, then your output is equal to 1, and you're talking about non-overlapping. So what I have told you in the previous session, simply blindly go to ideal state. Output is equal to 1. So this is how we are going to draw the sequence detector for the sequence 1100. Is it clear? Any doubts or any? So if you are having doubt, like when you are in S3 state and if your input is equal to 1, why are we going to S1 state? You can write down the sequence and you can check it. Okay. Like you can build your own sequence 0, 0, 1, 1, 0, 1, 1, 0, 0. Like this, you can check this. Okay. So you can assume that from S3 state, you can go to ideal state and you can check whether your FSM is working for this particular sequence or not. Okay, you will come to know. Okay, yes. So this is how you are going to draw a FSM state diagram for the sequence 1100. Okay, it is Mealy non-overlapping. Now let us see for Mealy overlapping. So let us see for the sequence Mealy overlapping 1100. Okay, if I apply reset, then I am going to a state which is known as ideal state where no bit is matching and 0 stay in the same state. 1 go to next state which is known as S1 state where your output is equal to 0 only. Sorry, it is a Mealy FSM, right? If you get one more 1, you stay in the same state. Output is equal to 0. If you get 0, you go to next state which is known as S2 state. Okay. Now, sorry, this is 0. This, okay, 1. And if you get 0, go to ideal state. Okay, your output is equal to 0 and 1 1 followed by one more 1 stay in the same state, output is 0 itself, and if you get one more 0 you are going to a state which is known as S3 state. Okay, so Mealy overlapping and Mealy non-overlapping will look the same for up to some particular states. Okay, now from the last state, we have the sequence when we are in S3 state, we have the sequence 110. We have the sequence 110. And if we get one more 0, what should be our next state? So our sequence is getting matched. Okay, I'm talking about overlapping. And if I get 0, then my sequence is 1100. Then what should be my next state if I am in S3? Can you simply idle? If my input is equal to 0, output is equal to 1. Why I'm going to ideal state? Because my last bit is equal to 0. Using this 0, it cannot be act as a starting bit. Okay, so because my starting bit is 1. Okay, so that's why I'm going to ideal state. Okay, I cannot overlap also with, I cannot use it for overlapping also. Okay, now if I get 1, okay, if I am in S3 state, I have the sequence 110, and if I get 1, then I can reuse this 1 for making the sequence 110, 1100. That's why I'm going to a state which is known as S1 state. If my input is equal to 1, output is equal to 0. Is it clear? Any doubts or any queries in this Mealy non-overlapping and Mealy overlapping? Please let me know. What is my approach in this particular questions is, first I am trying to discuss all the level 1 questions. So I have divided these questions into three levels. Okay. Level 1 questions are single sequence detections. Single sequence detection. Okay. So like 101, 1100, 1010. Okay. These are all single sequence detections. Next, coming to level 2. What is level 2 is here, if you carefully observe, like when we were discussing about 101, 00, 101, 00101. Okay, so we are having this particular sequence. When we were detecting this sequence, we are making our output to 1. Okay, up to here our output is equal to 0. Okay, and here again, after the sequence has been detected, we are making our output to 0 immediately. But in the level 2 type of problems, what we should do is we should not make our output simply to 0. We should maintain our output to 1 itself. Okay. Again, if the sequence has been detected, then our output should become 0. Until then, our output should become 1. Okay. This type of sequences, I'm naming it as level 2, that is toggling output. Okay. This is level 2. And coming to level 3 is multiple sequence detections. Like this, I have categorized the problems. Okay. Multiple sequence detections. And I have level 4 also. So basically, this level 4 is divisibility type of problems. Like you should check for the you should check whether the number is divisible by a particular number or not, like divisible by 5 or divisible by 3, 5, 7, or so on. We should design a FSM for this divisibility check. Okay, like this I have categorized this particular problems. Okay, so let's go step by step. So first we have we are discussing about single sequence detections, where we are considering all the non-overlapping overlapping sequences. Okay, yes, so if you are having any doubts in level 1 set of problems, please let me know. We will discuss it. After that we will go to level 2. So this is the classic example of overlapping and non-overlapping, where we have a sequence 1010 to be detected. Okay. Okay, let us take 101. 101 should be detected. Okay. Now, in the case of non-overlapping sequence detection, if your sequence has been detected, in our case 101 has been detected, then you should not consider the bits of the previous sequence that has been detected. That is in this case, you should not consider this one of the previous sequence. You should start checking from this fresh bit itself. Okay. But in the case of overlapping, your present sequence can be overlapped with our previous sequence which has been detected, like this, the green box you can see, right? So what you can do is you can also consider the previous bit which is present in the previous sequence that has been detected. Okay, this is a case of overlapping and this is a case of your non. Next, any doubts or any queries? Shall we move to level 2? So let us move to level 2 set of problems. And one particular pattern, if you carefully observe, is for if you are designing a FSM for a 4-bit sequence, then you're in the case of Mealy FSM, in the case of Mealy FSM, you are getting 1, 2, 3, 4. Okay, sorry, yeah, 1, 2, 3, and 4 states. But in the case of Moore FSM, you will get 4 plus 1, that is 5 states. Where is this Moore? Yeah, in the case of this Mealy overlapping, for 3 bits you are getting 3 states, whereas if you are designing it with the help of Moore, where is Moore for 3 bit? Yeah, this one. So you can see n plus 1. Okay. So for n bit sequence detection, you will get n states in your Mealy FSM, whereas you will get n plus 1 states in the case of Moore FSM. This is not for all the levels. This is only applicable for level 1 set of problems. Okay. So I will write down here for n bit sequence detection, number of states required, number of states in Mealy is equal to n, whereas the number of states in Moore is equal to n plus 1, and this is only case for level 1. Okay, in the level 2, level 3, level 4, there is no compulsion that you will get the same things. Okay, yes. Now, so let us see this level 2 type of problems. This level 2 type of problems will come in the case of toggling output. So what do you mean by toggling output? We have a requirement. What is our requirement is we need to detect a sequence 101. Okay. Like let's say we have a sequence like this 00101001001. Okay. Let me change the color. So we have a sequence like this. This pattern has been detected and your output will become 1. Your output will become 1. And your output should be 1 itself. It should not become 0. Previously it was becoming 0, but here in this case it should not become 0. It should be 1 itself. When it should become 0, again this pattern has been detected, then it should become 0. Until then your output should be 1 itself. Okay. This we need to design. Okay. And in this also we have overlapping and non-overlapping. Okay, in this particular level 2 also we have overlapping and non-overlapping. First, let us try to discuss non-overlapping toggling output type of problems. Okay, so we need to design 101 Mealy non-overlapping toggling output. We need to design this. Okay, so how to design? So up to some extent the things will be same itself. Okay, let us see this. So if you apply the reset signal, your output will be 0 itself, and you are going to a state which is known as idle state where no bits are matching. Okay, and if you are going to apply 0, you are going to stay in the same state, and if you are going to apply 1, you are going to a state which is known as S1 state where 1 bits are matching. Okay, and you can take any name. I am comfortable with this S1 because I am used to it. Okay, if you want, you can take any other state names also. Okay, now if you are getting one more one, you are going to stay in the same state. Your output is equal to 0 itself. Okay, and if you are getting 0, 2 bits are matching, you are going to a state which is known as S2 state where your output is equal to 0 itself. Now, if you are in S2 state, you have the sequence 1, 0, and if you get one more 1, your pattern has been detected. Now, which state you should go? Whether you should go to idle state or whether you should go to S3 state. Can anyone tell me? If I am in S2 state, I have the sequence 1, 0, and if I get one more 1, my pattern has been detected. Which state should I go? I should go to idle state or should I go to S3 state? Previously, I was going to idle state, non-overlapping. Okay, what about others? And this is a toggling output. That means your output should become one. Your output should be one itself. Okay, until the sequence has been detected again. No, no, no. The pattern has been detected, right? Then your output will become one. Okay, this is my output. Your output will become one. Now your output should be one itself, and when it should become zero, until the pattern has been detected again, your output should be one itself. Okay, this is nothing but my toggling output. I will explain it one more time. Your output is initially 0 itself. This is 0 and it is becoming 1 and it is remaining 1 itself. Until the pattern has been detected again, it will be 1 itself and it will become 0 when the pattern has been detected. This we need to design. Now, so which state should it go from S2? Should it go to idle or should it go to S3? Okay, so you are saying that we will stay in the same state, huh? Okay, so I'm going to represent it in dotted lines. 1, 0 followed by 1. I'm going to stay in the same state where my output is 1. Okay. Now, if I get 0, instead of 1, if I get 0, which state should I go? I will go to simply idle state. There is no confusion because the sequence has not been detected. Okay. Now, if I am in S2 state, I am getting 101. Okay. If I get one more 1, then what should be my output? I'm going to stay in the S2 state only. My output is 1. And if I'm getting one more 0, then I'm going to idle state. And what is my output? My output is becoming 0, see? But my output should not become 0, right? Did you get it? If you're doing this, then you're not getting the required sequence. Did you get the problem here? Pardon? So our requirement is if the sequence has been detected, your output should become 1 and your output should be 1 itself until the sequence has been detected again. Okay. If the sequence has been detected again, your output should become 0. For this, we need to draw the FSM. Okay. Yeah. So one answer I have got is if my input is equal to 1, I should stay in the same state. But if I'm staying in the same state, I'm not fulfilling my requirement. Then what should I do? Okay, let me explain this. Let me erase this. Now, if I am in my H2 state and if I have the sequence 1 0 and if I get one more 0, my pattern has not been detected. I can simply go to idle state. There is no problem in it. Okay. But if I am in H2 state and I have the sequence 1 0 followed by 1, then the sequence has been detected. Then the sequence has been detected and my output should become 1. Okay. My output should become 1. And I can go to I cannot go to ideal state, because if I am going to have my ideal state like this, if I am going to my ideal state, if I am getting 1, then if I get one more input as 1, or if I get one more input as 0, my output is becoming 0. But what is my requirement? My output should become 1 itself. My output should remain 1 until the pattern has been detected again. Okay. So I cannot go to my ideal state. Okay. So that's why what I'm going to do is I'm going to a new state which is known as S3 state. I'm going to a new state which is known as S3 state. Okay. Let me draw that. If my input is equal to 1, output is equal to 1. Okay. Now, if I am in S3 state, I have the sequence 101. Okay. Now, if I get one more 1, what state should I go? So I'm going to stay in the same state. My output is 1 itself. Okay. But if I get 0, I will go to a next state which is known as S4. Okay. Now, if I am in S4 state, I have the sequence 1 0. And if I get one more 0, which state should I go? Pattern has not been detected. I am getting the sequence 100 and I am in S4 state. What should be my next state? Can anyone tell me? Hemasri, what was your question? I didn't get it. Moving to S1. Okay, okay, okay. Yeah. And Lakshmana, what were you saying? S4 to S4 to S2. Okay. So if we are getting 1 0 and if we are getting one more 0, yeah, exactly. So I'm going to simply S2 state. But if you go to H2 state and if you get one more 0, you are going to idle state by making your output to 0. But that is not our requirement, right? You cannot go to H2 state. Did you get it? Because if you go to S4 to S2 and if you get one more 0, you are going to idle state and you are making your output to 0. But your output should not become 0 until the sequence has been detected. So you cannot go to H2 also. Next, anyone wants to answer? My question is no, no. You cannot go to S1 also, because if you get any one input, then your output is becoming 0. Idle state also you cannot go, because if you go to idle state and if you get any one input, your output will become 0. But your output should become 0 whenever your output is detected only. Until then, it should become 1 only. So that's why simply go to S3 state. Okay. If your input is equal to 0, simply go to S3 state only. Okay. And yeah. And this was the case where you are in S4 state, you have the sequence 1 0, and if you are getting one more 0, you are going to S3 state. Okay. And when you are in S4 state, you have the sequence 1 0, and if you are getting one more 1, then what is the sequence 1 0 1? The sequence has been detected. simply go to idle state and your output is equal to 0. You can make your output to 0. So this is how you are going to design a 101 Mealy non-overlapping toggling output. Okay, once again check. So if you are having 1, you are going to S1 state. If you are having 0, you are going to S2 state. If you are going to have 1, you are going to S3 state by making your output to 1. Okay. And if you are in S3 state, you are getting one more 1, you are going to stay in the same state by maintaining your output to 1. And if you are getting 0, 2 bits are matching. Okay. 2 bits are matching. So you are going to S4 state by making your output to 1. And if you are in S4 state, you are getting 1,000, then no bits are matching. Then you should not simply go to idle state. Okay. You should go to S3 state. Okay. Because here only your output will become 1. Okay. If you go to S2 state or idle state, if any one of the next bit is equal to 1 or 0, your output is becoming 0. But your output should not become 0 until the pattern has been detected. So that's why you are going to S3 state. Again, if you are getting one more 0, you are going to sorry. If you are getting if you are in S4 state and if you are getting one more what you say 1, your output will become 0 and you are going to idle state. So this is how you are going to deal with it. Is it clear? Any doubts or any queries? Shall we move forward? Any doubts or any queries here? Okay. Let us see for one more sequence. 1, 1, 0. We need to design Mealy non-overlapping toggling output. Okay, we need to design this Mealy non-overlapping toggling output 110. Okay, so if I apply reset, I'm going to idle state and 0. I'm going to stay in the same state. 1, I'm going to a next state, 1 bit matching, followed by one more 0. Then I will go to idle state. My output is equal to 0, but if I'm getting 1, I'm going to next state h2. Now 1 1. Now followed by one more 1, I'm going to stay in the same state. My output is equal to 0 only. But if I'm getting 0, I'm going to a state which is known as S3 state. Okay. This is my Mealy non-overlapping for 110. Okay. If I get 1 S1, S2 and S3 is the state where 3 bits are matching and my output is equal to 1. Okay. Now, if I am in S2 state, if I have the sequence 111, I'm going to stay in the same state, and if I get 0, I'm going to S3 state. And if I'm in S3 state, I have the sequence 110. Okay, and if I get one more 0, and if I get one more 0, then which state? What should be my next state? If I am in S3 state, I have the sequence 110, and if I get one more 0, what should be my next state? If you go to S1, then if you apply any one more input, then your output is becoming 0. But your output should not become 0, right? That's why you are going to stay in the same state. Yeah. And your output is still 1 itself. And if you get one more 1, you are going to next state, which is known as S4 state. Okay. Now, if you are in S4 state, you have the sequence. If you are in S4 state, you have the sequence 1 1 0 1. Okay. Now, and if you get one more 1, if you get one more 1, you are going to a state which is known as S5 state. But instead of this 1, if you get 0, then which state should you should go? You should come back to S3 state, where your output is still 1 itself. Okay. where your output is 1 itself. Okay. Now, if you are in S5 state, you have the sequence 1, 1. If you are in S5 state, you have the sequence 1, 1. And if you are getting the 0, your sequence has been detected. You can go to ideal state because it is a non-overlapping sequence and your output is equal to 1. But if your output is equal to 0, yeah. But instead of the 0, if you are getting 1, you can stay in the same state. Your output is equal to 1. This is how we are going to draw our Mealy non-overlapping toggling out. So is it clear? Any doubts or any queries in this? Others, shall I explain one more time? Any doubts or any queries in this or the previous one? Okay. Shall we discuss one more example? For Mealy overlapping toggling output, non-overlapping and Moore it will be more interesting. Mealy is good. Moore it is more interesting and confusing. Okay. Once let us discuss about Mealy overlapping, then we will go to Moore. Okay. So one more final example. Mealy overlapping sequence for 101. And what is our requirement? It is a level 2 problem, that is toggling output. Okay. So what is toggling output? Again, I will explain 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1. Okay, this is my sequence. Okay. Coming to my output patterns, it should look like this. Here the sequence has been detected. My output should become 0. And since it is a overlapping sequence, sorry, your output will become 1. And since it is a overlapping sequence, you can overlap with the previous sequence and your output is becoming 0 here. Okay. And your output is becoming 1 here. And again, your output is becoming 0 here. Up till here, it will be 1 itself. This is our requirement. Okay, we need to design a Mealy overlapping 101 with toggling output. This we need to design. We need to design a state diagram. Okay, so let's see how to design this. If I apply reset, I'm going to a state which is known as ideal state where your output is equal to 0 and 0 you're going to stay in the same state, 1 you're going to next state S1 and 1 you're going to stay in the same state, 0 you're going to next state, and if you get 1 0 followed by one more 1, you should not go to ideal state. Okay, I will draw it. I will write down here. If you are in S2 state, you have the sequence 1 followed by 0. Okay, and if you get one more 1, which state should you should go? So you should go to S3 state where your output is equal to 1. Where your output is equal to 1. Okay. Now, if you are in S3 state, you have the sequence 101. And if you get one more 0, which state should I go? Can anyone tell me? If I am in S3 state, I have the sequence 101. If I am in S3 state, I have the sequence 101. And if I get one more 0, and I'm talking about overlapping toggling output, and I'm in my S3 state, what is my next state? Pardon? Okay. So I'm talking about overlapping, right? So I can overlap this 2, 1, 0. Okay. So 2 bits are matching. Okay. So that's why what I'm going to do, I'm going to a new state which is known as S4 state if my input is equal to 0 by making my output is equal to 1. Okay. So previously what was happening, if I am getting 0, I am going to stay in the same state. But here if I am getting 0, I am going to a next state which is known as S4 state. Okay, because it is a overlapping and two bits are matching. Okay, is it clear? But if I am in S3 state, I have the sequence 101, and if I am getting one more one, then what should I do? I am going to stay in the same state, that is S3 state only. I am going to stay. My output is equal to, okay, and here I should draw one more thing, right? L2 output is equal to 0. Okay, now if I am in my S4 state, I have the sequence. If I am in S4 state, I have the sequence 101 followed by one more 0. And if I am in S4 state, if I get one more 1, then what is the sequence? 101. The sequence has been detected. Then, and I can also reuse this one. I can also reuse this one. So that's why I'm going to S1 state. And my output is equal to 0. Okay, but if I am in S4 state and if my sequence is 1010 followed by another 0, then the sequence has not been detected. Okay, then which state should I go from S4? What should be my next state? Can anyone tell me? I will go back to S3 state. Okay, same as our previous diagram only. I'm going back to my S3 state if my input is equal to 0 by making my output is equal to 1. So this is how I'm going to design my FSM. Is it clear? So if you are having doubt, you can write down the pattern here: 0, 0, 0, 1, 0, 1, 0, 1. Okay. Or you can write 0, 0, 0, 1, 0, 1, 0, followed by one more 0, followed by 1, 0, 1, like this. Okay. So if I get 0, I'm going to stay in the same state: idle, idle, idle. And if I get 1, I'm going to S1 state. And if I'm getting 0, I'm going to S2 state. And if I'm getting 1, I'm going to S3 state. And my output is equal to 1. I can see here. Now, if I get 0, I'm going to S4 state. If I'm getting 0, I'm going to S4 state. And if I'm getting one more 0, I'm going to S3 state. And still my output is equal to 1 only, if you carefully observe. Okay. And if I'm getting again 0, I'm going to S4 state. But I'm getting 1, right? I'm going to be in the same state. I'm going to be in the same state, my S3 state, and my output is still 1 itself. If I'm getting 0, and I'm going to S4 state. If I'm getting 1, I'm going to S1 state by making my output to 0. Here my output is becoming 0. Here my output became 1, and here it is becoming 0. The pattern has been detected here, and again the pattern has been detected here. Is it clear? So this will this particular patterns you will get some little bit confidence if you practice it for just 2 to 3 times. You will get used to this particular things. Okay. Any doubts or any queries in this things?